The coordinates of 3 points are A, which is an x of k minus 5 and a y of minus 15, B, which is an x of 10 and a y of k, and C, which is an x of 6 and a y of minus k. Find the two possible values of k if A, B, and C are collinear. So if A, B, and C are collinear, it just means that they lie on the same line. So if you have A, B, and C, just an illustration of this, all of these points lie on the same straight line. So what this implies is that the gradient of AB, that gradient or that movement is the same as the gradient of BC. So all 3 points that are collinear have the same gradients between them. So this can help us to solve this question or find the values of k. So what we can do is say the gradient of AB is equal to the gradient of BC. So what would you do to find the gradient of AB? So all you would do is change in y over change in x. And what would you do to find the gradient of BC? Also just change in y over change in x. So the gradient of AB, you could say for the change in y, k minus 15, which we have here, over 10 minus k minus 5, which we have for change in x. And that would be equal to the gradient of BC. So change in y over change in x. In this case, we could say minus k for our change in y, and 6 minus 10. 6 minus 10. So you could do it the other way around. You could have also said k minus k over 10 minus 6. You'd get the same gradient. So we have these two equal to each other, so we can simplify this a little bit. So k minus 15 is k plus 15. 10 minus k minus 5. This would become 10 minus 5, which is 10 plus 5, which is 15. And you also have the minus k, which will stay there. And then minus k is minus 2k over 6 minus 10, which is minus 4. That just simplifies to k over 2. So now we're dividing by 15 minus k on the left. So to get rid of this 15 minus k from the denominator, we've got to multiply both sides by 15 minus k. And in the same way, we're dividing by 2 on the right side. So to get rid of this 2 on the right side, we've got to multiply both sides by 2. So this will give us 2 times k plus 15 when you take the 2 up here. And then when you take the 15 minus k and multiply on the right side, you'll just get k times 15 minus k. And now we just simplify this and solve for k. So we get 2 times k, which is 2k, 2 times 15, which is plus 30, k times 15, which is 15k, and k times negative k, which is negative k squared. So we take minus k squared, we take it to the left side, so we're going to add k squared on both sides. This will just help us to make this k squared positive. And then we're going to take the 15k also to the left side. So this is going to give us k squared, and then 2k minus 15k is minus 13k, and we'll be left with the plus 30 still. That's all equal to 0. And now we factorize. So factors of 30 are 10 and 3. And using those factors, we'll have k minus 3, k minus 10, all equal to 0. So this means that k minus 3 has to be 0, or k minus 10 has to be 0. So therefore, k equals 3 or k equals 10 are our solutions. So when k equals 3 and k equals 10, this line is going to be a little bit different because the coordinates of A, B, and C will have different coordinates. So when k is 3, for example, if you substitute 3 wherever you see k's in these coordinates, our line will look like this. A will become minus 2 minus 15, because 3 minus 5 is minus 2, and the minus 15 doesn't change. And then for the 6, it will be minus k in the y, so minus 3. And for b, it's just 10 and k, so 10 and 3. So that's when k equals 3. And very similar, if you go and substitute 10 in place of all of these k's, your line will look like this.